Okay, so in this video I'm going to have a look at the Leaving Certificate Higher Level Paper 1 for 2018, and I'm going to have a look at question 2. So this is a number patterns or sequences in series kind of question, and in part A we're looking at the first three terms of a geometric series, which are x squared, 5x minus 8 and x plus 8. Now we've got to use the common ratio to show that x cubed minus 17x squared plus 80x minus 64 is equal to 0. So it's really telling us what to do here. It's telling us to find or to use the common ratio to show that this is equal to 0. So in a geometric series, you're multiplying any particular term by the common ratio to find the next term, and then you're multiplying that term by the common ratio to find the next term. So in other words, if we have, say, these three terms here, if we divide the second term by the first term, we'll get the common ratio. Similarly, if we divide the third term by the previous term, the second term here, we'll also get the common ratio, so they should be equal. So in other words, 5x minus 8 divided by x squared should be exactly the same as x plus 8 divided by 5x minus 8. So for example, if you have a geometric series, let's say 2, 4, 8, 16 and so on, here our common ratio is 2, or is equal to 2 in this particular case. So you're multiplying each term by 2. So if you divide 4 by 2 you get 2, if you divide 8 by 4 you get 2, if you divide 16 by 8 you get 2, and so on. So here all we've done is taken this divided by x squared, taken x plus 8 divided by 5x minus 8, and we should get the same term. Now presumably then this is true, we know this is true, so presumably if we work this out we should end up with this here. So let's just do that. So what we're going to do is just simply cross multiply here. We've got a fraction equal to a fraction. So I'm going to take the top here, 5x minus 8, and I'm going to multiply it by the bottom here, which is also 5x minus 8. I'm going to take the x squared, I'm going to multiply that by x plus 8. So multiply this out then, and you will get 25x squared minus 40x minus 40x and plus 64. On the right hand side, just multiply all this out, we get x cubed plus 8x squared. Now if you bring everything over to one side, you will in fact get this here. So let's bring this, we have an x cubed on this side here, so let's just leave the 0 on this side. We'll bring all of this over to this side here. So we've got an x cubed here on this side, so let's leave that there. Let's take this 25x squared and bring it over to this side, so we'll get 8x squared minus 25x squared, that's minus 17x squared. We've got minus 40x, that's minus 80x. Bring it over to the other side, we'll get plus 80x. And then we've got a plus 64 here, so subtract 64 from both sides. And so this is true, this is fine, or QED, or whatever way you want to finish this here. But this is what we were asked to show. Okay, so let's look at the second part here. Now it says that if this is what we ended up with in part A, so x cubed minus 17x squared plus 80x minus 64. So this is our function f of x. Show that f of 1 is equal to 0, and then find the other value of x that will also give us 0 when we substitute it in here. Now this is a cubic expression, or a cubic function, so we should have 3 roots here. So let's start anyway by substituting 1 in. We've got to substitute 1 in for x here. So we have f of x here is equal to x cubed minus 17x squared plus 80x minus 64. Let's substitute in 1. So we've got 1 cubed minus 17 times 1 plus 80 times 1 minus 64. So let's just work this out and see what we get. Well, 1 cubed is 1, 17 times 1 is 17, 80 times 1 is 80, minus 64 here. So here we 1 minus 17 is minus 16, 84 minus 64 is plus 16, so we get 0. So in other words, x is equal to 1 is a root of our function f of x. So now we have the root. That means, using our factor theorem here, if you like, x minus 1 is a factor of x cubed minus 17x squared plus 80x minus 64. So in other words, we can divide in this x minus 1 into our function, and that will give us our other factor. So we just got to do a little bit of long division here. So we've got to take our x minus 1 and we've got to divide that into x cubed minus 17x squared plus 80x and minus 64 here. So we've got to divide it in. We know this is a factor, so if we divide it in here, it'll give us our other factor up here. So let's do that. Well, x into x cubed is x squared. Multiply the x squared by these two here. Write your answer down here. So it's x cubed, and then x squared times minus 1 is minus x squared. So we're just going to put that down here, and we're going to subtract. So plus x cubed minus x cubed, 0. Minus minus is plus, so this is a plus x squared here. So we end up with 17x squared plus x squared, which is minus 16x squared. We're going to take our next term and just bring it down here. So that's plus 80x. Okay, next one then, we just start again then, divide the x into minus 16x squared. That'll give us minus 16x. Multiply the minus 16x by these two here, write our answer underneath here. So minus 16x times x is minus 16x squared. Minus times minus here is plus. 16x times 1 is 16x. Put a line underneath here, and we're going to subtract again. Okay, so here we have minus minus is plus, so these two will cancel here, or we'll get 0 down here. Minus times plus is minus, so this is a minus 16x here. So 80x minus 16x is 64x. Okay, so the last one then, we're going to take this minus 64, bring it down here, and start again. So x into 64x is plus 64. Multiply the 64 by these two, and we get 64x, and we get minus 64. Again, just finally, you can just subtract here, and you'll find that that will give you 0. This here will give you 0. So we have no remainder, which is what you would expect. We know that x minus 1 is a factor. It divides into this cubic expression here. So this is our other factor here. In other words, our x minus 1 and our x squared minus 16x plus 64, if we multiply these two together, we'll get our cubic expression here, our function here. So we got to factorize this quadratic now. So really what we got to do is break that up. We got to factorize this part here. So we got x minus 1 here. I'm going to factorize this. This will give me x times x. 64 will be 8 times 8, because we need a 16 here as well. We want a plus 64, so it's plus times plus, or minus times minus. Because this is a minus, I'm going to put in two minuses here. So these are our three factors. So if there are three factors, then we know that these have to give us 0 to find our roots. So x is going to be equal to 1 or 8 or 8. So because x minus 8 is equal to 0, x minus 8 is equal to 0. If x minus 8 is equal to 0, x is equal to 8. So these are our three factors. So when in the question they said find the other value of x, despite the fact that this is a cubic function, we should have three roots, but the other value singular means that we did really only get one value here. We got 8, so this is a repeated root. So really our function really looks something like this. I just plotted it here on GeoGebra, so you can see it here. You can see the 3 roots here, and we have a repeated root here. So if I just zoom in here a little bit, you can see where the 3 roots are. You can see you've got x is equal to 1. Here is one of the roots, and here's our 8, our repeated root. You can see the graph comes down, hits the x-axis, and comes back up again. So we have a repeated root here at x is equal to 8. Okay, so our answer to this part of the question, what does the question say? First of all, it just says show that f1 is equal to f of 1 is equal to 0. We've done that here. And find the other value of x. So the other value, our answer, if you like, our answer here is just x is equal to 8. Okay, so let's look at the part C then, the next part of this question. So in part C here it just says in the case of one of the values of x from part B, the terms, and remember the 2 answers to part B are x is equal to 1 and x is equal to 8. So what we've got here is the terms in part A will generate a geometric series with a finite sum to infinity. And remember, our sum to infinity is a over 1 minus or, where or, the modulus of or here has to be less than 1. The modulus of or has to be less than 1. In other words, really or has to be a fraction. Now, we can check these. We know that our 3 terms are from part A, they're x squared, they're 5x minus 8, 5x minus 8, and we've got x plus 8. Now we only have 2 options here. We can say x is equal to 1. So if we have x is equal to 1 here, our 3 terms would be 1 squared, which is 1, 5 ones are 5, minus 8, which is minus 3, and then 1 plus 8 is 9. If x is equal to 8, on the other hand, we would end up with 8 squared, which is 64. We would have 5 eighths, 40. 40 minus 8, 32. And finally, we would have 8 plus 8, which is 16. So these are our 2 options for our geometric series. So let's just have a look at these. Well, I've actually written them as a sequence here, but anyway, let's have a look. In this particular case here, we would have an OR value. Our OR, remember, is this term divided by this term, or this term divided by this term here. So it would be minus 3 over 1, or 9 over minus 3. So that would give me minus 3, an OR value of minus 3, a common ratio of minus 3. But remember, to generate or to find our sum to infinity of a geometric series, we would need to have a modulus of OR less than 1. But the modulus of minus 3, is 3, which is not, I shouldn't say not equal to, it's not less than 1. So we can't use this here. Now what about here then? If we take this series here, 64 plus 32 plus 16, I'll write it as a series. Really this should be 1 minus 3 plus 9, if you like. Continue that on. So if we take 32 divided by 64, that'll give us a half. Now the modulus of a half is a half. The positive value of a half is a half. And this is, which is less than 1. So this we can use. So our OR here is a half. And A is going to be 64. So what's the question? The question says, find this value of x. So the value of x, our answer to the first part is really just 8. This is the answer to the first part of the question. X is equal to 8. and hence find the sum to infinity. Well, the sum to infinity then is just going to be, remember our three terms now are 64. Let me just do that in white here. So we got 64, no, let's go back again, try once more. Okay, so we have 64, we have 32, and we have 16. So this is our geometric, I'll write it as a series here again rather than a sequence here. So it's going to be plus and plus here if you like. So we have a is equal to 64, and we have our or here is equal to a half. So our sum to infinity is equal to a over 1 minus or. So in our particular case here, our a is 64, so that's going to go on top here, and we have 1 minus half on the bottom here. So that's going to be 64 divided by a half, which is just 64 divided by a half is 128. So our sum to infinity, our second answer here if you like, is 128. Our sum to infinity, so that's our sum to infinity. And the answer to the first part of the question, as I say, is x is equal to 8. Okay, so that's really it for question 2.